Hello everyone, this is Professor Maloney, and today I'm creating an overview video presentation of Chapter 3. Okay, so Chapter 3 means that's the third chapter or third unit out of 8 in the class, and the second with programming exercises. This particular video is going to hopefully give a good overview on what you need to review from the PowerPoint presentation for Chapter 3. But remember, as I mentioned with the Chapter 2 or Unit 2 overview, you also still need to read that ebook, okay? And you access the ebook from MindTap, okay? All right, so for now, I'll go ahead and start my screen share here and show you where to go to get the PowerPoint. All right, so we're going to go over here to our PowerPoint slides. Okay, and Module 3, PowerPoint. Okay, this will download here in a little bit. Okay, it has done so. All right, so now I'm going to just go ahead and enable the editing and make it big and go ahead and run it from the F5 mode so we can see everything. All right, okay, so here we go. Now, Chapter 3 is dealing with input and output. And as I mentioned with Chapter 2, I don't like to go slide by slide. Depending on what I see on these, I may have to, go slide by slide for at least a little while. Excuse me, I'm having a little drink as we do this. All right, so learn what a stream is and examine input and output streams. So, every time we send something to the screen, remember that is an output and it is technically a stream, meaning if we just write out a simple COOT statement and we send it to the screen, that is an output stream. And when we get input from the user via the C input or common input line of code, then we're actually getting an input stream, right? So it's not just meaning characters and not just meaning words, one or two, but we'll also, in this chapter, be giving an introduction to file streams. And the file streams, we're going to use a text file. We're going to have a text file that we're then going to be used to read our CPP file, meaning some code, some variables, etc., that we will have in our C++ file. And we'll use that in file or in data file, input file, whatever you want to call it. We'll use it to create then an output file, okay? Now, we're only going to, I think there's one up here programming exercises from 3.1 through 3.6 that requires you to do this, but we will, I will demonstrate it, not in this video. As always, remember, I'm going to be doing either 1 or 2 additional videos. So this one's the overview, just what the chapter is about. And then I'll have one where I talk about formatting output, and I'll be doing another where I talk about using an input file and creating an output file with it, okay? All right, so explore how to read data from the standard input device. You've already been doing that, right? Remember, the standard input device is just your keyboard. So as we're typing input, that is what we're doing, and that is an input device. That's how we read data. We are also going to be using predefined functions in a program, and these predefined functions are elements of the programs. In this particular chapter, we're already going to add 2 different pound include statements in addition to pound include IO stream. We're going to be using pound include IO manip, and that stands for input output manipulator. And basically, we use that to format output. If you remember in Chapter 2, I said, or again, Unit 2, I said that we would not be formatting output in Chapter 2, but that we would be starting for sure in Chapter 3. So here, we're going to set some output parameters up where perhaps we want every number, let's say, to have 2 decimal places, or all double numbers anyway, to have 2 decimal places. So we'll do that with IO manip. And there's also pound include string. And I mentioned this in Unit 2 as well. And in this particular chapter, we're not going to really expand too much on the string, but I will show you one thing. Well, in this one, I'll explain a little overview talking about how you can do a getLine function as part of the pound include string so that you can get a sentence or even more, of input and throw it all into one variable, okay? All right, so then we're going to also talk about the input stream functions. So when we're talking about an input stream, we have certain functions that are built in. A get function allows us to get the next character. As an example, with a SYN statement again. Remember C input, so we're getting information from the user. So we might have like a CIN.get, and then we'd have an argument. Remember, arguments have open and closed parentheses. And with those open and closed parentheses, we would put what the variable is that we're trying to get. And if it's only a character, then it's going to be a char of some type. But we would have it within that argument. Okay. There's also a ignore function, and the ignore function has us basically discarding portions off the X number of characters that are coming after something. And we might be, as an example, waiting to go until we see a new line character, or we might just want to delete the next 50 characters, whatever numbers that we might want to do. And that would then be similar to getting the next character, but in this case, we're going to ignore them, okay? And we also would have a putback. A putback function allows us to place the previous character that was extracted back into the stream, okay? So it puts it back into the stream. There's another one that's similar to putback. It's called peek, but peek allows us to see what the next character is, but it doesn't technically have that. It's not returning the function from that character from the stream, because it's only letting us see it in advance of actually showing it. Okay, so get, ignore, putback, and peek are things we use with file streams quite a bit. All righty. All right. Let's see here. Become familiar with input failure. So input failure, obviously, we're going to make mistakes. All right, some of the input failure that we might get when we're running any given program is if we're having a char as an example, and remember char, the char data type is only one character, okay? And if we are pulling information, especially from text files, right, where we're perhaps reading hundreds of characters, or it could be thousands of characters, if we get a char mixed up with either an int or a double, which is obviously an entire number, right? The number might be 1, which also does have a char. Remember, so what is a char again? We might need to just sort of touch up with. A char has a single quote around it, all right? A number does not. So if we're talking, and remember I said that a char is any character from our keyboard. So the number 1 on our keyboard comes up to being a char of more or less 49 or so, maybe 50 or 51, but it's not the number 1. So anytime if we're using the char data type and that char actually is 1, then we want to make sure that in the ASCII world, it's 49 or 50 or 51, whatever the value truly is in a char or in a character sense. But if we're using a char, and we really mean the number 1, it's an entirely different number. So therefore, that can be big input failures, okay? We want to learn how to write data to the standard output device. You've already been doing that with COOT statements. Remember, C output statements. So, and what is the standard output device? Of course, that's the monitor, right? Discover how to use manipulators in a program to format output. We're going to be using quite a few manipulators in this chapter, and to use them, I think I already mentioned that we'd be using #include IO manip, okay? And with #include IO manip, then we can have some functions that we want to use, which are built in based upon using IO manip, so that we can then have fixed decimal types. We can have what we call show point, and we can have what we call set precision. You need all of these: fixed, show point, and set precision, and they're all separated by less thans, okay? So meaning they're on the input side. And we would then do them with the set precision, okay? Normally we put 2 as an argument for that one, so that we get all our values output with 2 decimal places, okay? So that's manipulators. Learn how to perform input and output operations with the string data type. We touched on this in chapter 2. We're really still only touching on it, but I mentioned that we'd be using one statement which might be important even on your test, okay? Your test for chapters 2 and 3, which will be coming up more or less at the end of September, maybe September 28th or so, I believe. But either way, we might be using a get line. Get line allows us to get an entire line of a string variable, okay? Could be 100 or more characters long. And as an example, if you're using something to get a full name, what's a full name going to be? Like in my case, would you say professor and then space and Maloney? If it's just professor, then you can have string first name, or in this case, string job title or something. And then for the last name, string last name. But if you want full name, right, then you normally want those spaces in between. Okay, so we'll be talking about this, especially you're going to want to pay attention and look up in your PowerPoint, and also look up in your ebook for using getLine. Okay, getLine. That's one word, G-E-T-L-I-N-E, all underscored. All right, and then we'll learn how to debug logic errors. Remember, we talked about syntax errors, right? A syntax error stops the program. Stops the program because something was not right, meaning a variable. Normally they're simple syntax errors where maybe we spelled a variable differently. We used different case on a variable, okay? Things like that. We didn't have an open parenthesis, but we did have a closing parenthesis. Or we had an open curly brace, but we didn't have a closing curly brace. We didn't spell one of our pound include statements correctly for the preprocessor directives, or they're what we sometimes call the header files. So, they're syntax errors. But logic errors, I talked about in class once or twice. One example I specifically mentioned was saying if we have buttons for Spanish and English and Creole, let's say, and if you click the Creole button, you expect to get Creole output. That's what you're expecting the button to do. But if it provides English, then obviously it's not a syntax error. Syntax errors can't determine what's right or wrong. It's just looking for syntax or syntactical statements and making sure that they're correct. Logic errors are where things are different. So if you have a formula and the formula is wrong, well, you're going to get the output based on the formula you typed in, but if that doesn't get you the right answers, then of course that is a logic error. So how do we figure out logic errors? Well, one good way to do so is to put little COOT statements after a formula where you put a test case so that you know what the answer is, and then verify that your program gives that particular answer. If it does, then you just comment out the COOT statement for the logic error, because now you verified, yeah, this is good. So that's all debugging logic errors means. It means for us to check to make sure that what we think is a good calculation is in fact a good calculation. All right, and of course become familiar with file input and output. We're not going to go too far into it, but like I said, we will have an example. You have an example. Well, in your case, it's not an example. You have to do programming exercise, I believe it's 3-5. I may be off, but it might be 3-5. But either way, it's between 3.1 and 3.6 for chapter 3, in other words, where you do have to have a file input, meaning a text file, and a file output. So the file input will be given to you, okay? But then you're going to have to create an output file, and you have to create your C++ code to know how to receive the input file and to know how to create the output file, okay? All right, so input, output, sequence of bytes from source to destination. So bytes are usually characters. Remember, for one byte is made up of 8 bits, and one byte is one key on the keyboard. So the letter A, the letter B, the number 1, the space bar, they're all bytes. So they're characters, and these characters turn into streams when it's a sequence of characters together. So from the source to the destination. So when we are inputting data from a text file, that's an example of taking a sequence of characters, could be dozens or hundreds or thousands. We don't know how many. And we have to be able to do it on the input side as what we call an input stream. So that's a sequence of characters from the input device to the computer. And then the output stream is when we're going to our monitor, right? Or in the case of the one programming exercise example from this chapter that you have to do, where you output information to a text file. Remember, text files are what we call simple text editors, okay? So you'll be using that. Use IO stream header file to receive data from the keyboard and send output to the screen. We've been doing that, right? So that's your pound include IO stream in this case, all right? So you have to have the ability to receive and send output. We're going to be using two what they call data types. iStream, that's the input stream. So in the case of a text file, that's the input to our C++ program. And then we take that input, code our C++ program to create answers for it or output from the input file based on how we want to format it, and then send it to an output file. So there's two variables with an IO stream. You have to have the CIN for the common input, meaning again, that's how you're going to get the data from the text file, and the COOT statements to send that information to the output file, okay? All right, so variable declaration is similar to, iStream. In this case, the I stands for input. So iStream and then CIN, meaning we're going to get that input from the user. OStream, COUT, or C output, common output, when you're sending the information to the other file. Right? So to use CIN and COUT, the preprocessor directive pound include IOStream must be used. And then for the input stream variable, we're going to assign a text file, to iStream. And we're going to assign a text file to the OStream. So again, we're going to have an input file, we're going to have an output file. The input file will be used with iStream. The output file, after we do what work we need to do on our program, then the OStream, which is the output stream, will be used to send that same information to a text file. So there'll be two text files at the end. We start with one that's given to us, we do the coding, and then we have another text file that's created automatically in MindTap. And again, I'm going to give you an example in the next few days of this, all right? Okay, so the syntax of an input statement using CIN and the extraction operators, we've done this. We've done this many times already. So CIN, and then a greater than variable, greater than variable, and then ... means, remember I did this with the test 1, test 2, test 3, test 4, and test 5 example I did in class last week, so during week 3, all right? You can do them as CIN greater than, and then variable, meaning let's say test 1, and then you can have a semicolon if you want. Or you can do an endl and then a semicolon, and then copy it and paste it into a new line. Obviously, first you'd have another variable name, or you can just do one CIN statement with 3 or 4 or 5 or 6 or however many of the variables you have. So again, CIN greater than, test 1, greater than, test 2, greater than, test 3, etc. End it with a semicolon at the end. The extraction operator is binary. That just means that the left side is the input stream, that's the C input in this case, and on the right side is the variable, right? So we've done this quite a bit already. Okay, so now there's no difference between a single CIN with multiple variables, and I demonstrated this too in that little example from chapter 2. I coded it and I showed you guys that we can have it, and then I actually did it for you in class where I had them on one statement. So like where you see here, CIN greater than pay rate, greater than hours worked. What that means is whatever the user types in first is going to be assigned to the pay rate variable. And then we would tell them, of course, put a space bar, hit the space bar. And then the next one they work, the next one they input is going to be assigned to hours worked. But you can do it as you see it there on the third line on this page, CIN greater than pay rate, greater than hours worked, semicolon, or then they skip a space and they do it as two separate C input statements. So C input pay rate, semicolon, C input hours worked. Obviously, that way it might look easier It just depends on you. But when scanning or when the user is inputting information, I mentioned to you that white space doesn't count, but it does tell us that it's then going to the next variable, assuming there's another variable, right? But anytime you have greater than, when it says skips all white space, just look at this first line up here. It could be CIN greater than, pay rate, where pay rate is bumped right up to that second greater than sign. That doesn't matter. Or pay rate may be over here. And literally, the person may have hit the space bar 10 times, 20 times, 30 times. It doesn't matter. White spaces are skipped is what it means, okay? All right. Now, remember I talked about character 2 and the number 2, right? So obviously, the right side operand is the variable, okay? So if we have a variable with a character 2, meaning a char, that should have a single quote 2, single quote. The number 2 should be an int or a double, and it would not have a single quote on either side of it, right? So if the type char or int or double, the 2 is treated as a character or as a number, respectively. And again, depending on the variable is all that means. All right. All right. Valid input for a variable up to simple data type. So you know that a char is just one printable character. Okay, one printable character. An integer is a whole number. An integer possibly preceded by a plus or a minus sign. When it's a variable, you can have like int space plus 217. You can do it that way. Or int space a, if that's what I just said, equals minus 217 or whatever, right? So, but an integer is a whole number. A double is a number that can have a whole bunch of decimal places, and it can also have a plus or a minus sign in front of it, okay? But with a char, once you have it initialized, meaning it's been assigned, it's assigned with a single quote and then the one character and then a single quote, okay? So entering a char value into an int or double variable causes serious errors because a char cannot be converted to a number, even if it's the number, like as an example, again, let's look at the number 9 on your keyboard. And I'm just going to go ahead and, let's see, I'm going to, for now, stop this and go in to find ASCII. So let me just, whoops, shoot, I don't want that. Oh, you know what, I want to escape out of there that way. I'm going to go into here. I think I just skipped when I hit the escape or whatever I did. So let me go over here. And I'll say 9 in ASCII, okay? So 9 in ASCII, so here's the binary, all right? So the 9 is this. So this is 1, that's 2, that's 4, that's 8. This is the number 9, okay? But if we want to see it in the ASCII characters, okay? They're not showing me the ASCII there, so I need my ASCII code. It's a range, maybe? Let's see. All right, well, here's one for 0, 0. Okay, there. The decimal code for digit 0 is 48. So when I said 49 for 1, that was correct. So 48 is 0, 49 is 1, 50 is 2. So a 9 is about a 56 or 57, all right? So point being, that's not the number, right? So a 0 is in fact 48 so if you do single quote 0, single quote, that's actually a 48. That's sure not the number 48. That means the equivalent number in ASCII. ASCII, American Standard Code for Information Interchange. All right. So that's what that thing is what I'm trying to emphasize with our PowerPoint here. And I think I skipped a page here. Did I skip 2? Let's see. Yeah, right here is where I was. Okay, so C input and the extraction operator. When reading data into a char, skips the leading white space. Remember, white space is ignored. It's finding and storing only the next character. Now, the number, a character can be a number, right? And to read data into an int or double, it's the same thing. It's going to skip any leading white space, but it's looking for digits. And there's going to be an example coming up here, and I'm going to read those carefully. Maybe right here. Yeah. All right. So these right here, if we have this code or these declarations, int a, b, double z, char, ch. So we have 4 variables. 2 are integer, 1 is a double, 1 is a char. Now, if the input is a capital A and it's following the statement cin, remember again, it's from the user, so therefore we have the greater than signs as opposed to the less thans because we're getting the information from the user. User types in a capital A, we're going to assign the capital A to the ch, which is a char. So that means in memory, it's stored as a single quote, capital A, single quote. That cannot work as an integer or a double, okay? So that would cause input failure. So sin greater, ch. In this case now, if they have AB as input, well, you can only, with a char, it's only 1 character, and it's the first character. So in this case, AB, the A is ch. So that's what's assigned to the variable with single quote around it. And the B is sitting there. It's waiting either for another sin, like cin char 2 or something, right? But we don't have a ch2 up here. We only have these. But the point is, it doesn't take AB because it's a char. It can only take 1. All right. So then the cin with A, it's an integer. So 48 works. Cim with A, where the input's 46.35. Well, what's an integer? It's 46. The 0.35 is quote unquote held for later input. But if we would have had this as cin greater A, then greater B, Z for double. Okay, so we had 2, A and Z. 46 would go to A and 0.35 would go to Z, even though they're written consecutively. So you assume the user meant 46.35, but if there was an int and if there's a double, then that would take the whole number would go to the int if that was the one that was listed first. If it was the other way though, where Z was listed first, well, the 46.35 is a double, so it'd take the whole thing. But if it's int A first, right? So we're saying here the A, and then I'm pretending there's another greater than Z, then 46 would be taken for A. The 0.35 in this case says held for later input because in other words, it can't be used with an integer, all right? All right, so Z 74.35 obviously takes the whole thing. CIN, Z here, 39, technically in memory, it adds a .0 or a 0.0 because it's a double. So even though it's a whole number, double stores it with a period 0 at the end. CIN, Z, and A. See here, the Z is the double, A is an integer. All right, so here we've got 65.78 and 38. That works perfectly because 65.78 is a good double, right? So that whole number, 65.78, is in the variable Z. And then there's a space, so then the next variable, which should be A, is 38. Where am I? 78. 38, sorry, then the whole value of 38 would then, it is an integer, so it would go to A. So in other words, number 7 here, you'd put a big check mark. Yes, that's exactly correct. It works well. CIN A and then B. So 4, yeah, of course, that's A. That's an integer. 60, sure, that's an integer. It goes to B perfectly. So CIN, and A and Z. Here, though, we got 46. So that's an integer. That works. 32.4, that's a double. That works. But we also have 68, but we don't have a third variable. So 68 sits there. It's not used. Okay? All right. Taking too long on this now, but that's okay. So a couple more of these examples. So CN, A, and Z. I'll skip now all this stuff. So A and Z. Well, we know A is an integer. So that 57, yes, that's good. And then they're looking for a Z. Oh, sorry, they're looking for char actually. So CH is the char. So A, that works because it's after a space. And then after another space, 26.9, and that's a double. So all of these work. So first one is integer. The second goes to the char. The third one goes to the double. Perfectly. Put a check mark. Goes good. A, CH, and Z in the next one. So here, it's the same thing. You have a 57. Then there's a bit of white space, one space, and then an A. So A is the integer. CH is the A, which makes sense. So it's got the single quote around it. And then even though it's another line now, so there was a hard return, so white space doesn't matter though, but this is still technically a good number for a Z, so this one is still used. So whether it's from left to right or left and a bit right and then a new line, it still comes out perfectly fine. So that's a check mark. That's perfectly fine. Now here, on the third example in this one, CIN, A, CH, and Z. So A57, another new line for A for CH. Yes, that works. Another new line for the Z, the double, 26.9. It works perfectly. So also a big, so check mark on all three of them. Now the next one, 57A, 26.9. So there's no spaces at all. So what do we have? Well, we have an A. What is an A? It's an integer. So A will take the integer. It won't just take 5 because 57 is an integer. So 57 is assigned to A. And then we got a char actually. So we got a char of A. So that works. Actually, this one's going to work. So 57 goes to A goes to the CH, and then 26.9 is a perfectly good valid double. So every one of those works, okay? But they only work because with no spaces in between, a number can't have a character, okay? And a character in this case, obviously the letter A cannot be interpreted as a number. So once the A variable is called, it's looking for an integer. So first it's looking at 57A26.9. Well, the 0.9 can't work, so it's thrown away. Then it's looking for 57A26. Well, the A can't work. So then the A and the 26 are thrown away, and it's only 57 left. Then the CH, there's no 57 anymore. It's already assigned. A 26.9, well, the A works, but the 26.9 can't work because it's more than one character, so it stops after A. And now we got 26.9 left, and it goes into the Z, which is the double. Perfect, perfect. Okay, another one. Let's see here. Suppose you have the following, same thing, A, B, Z. Oh, now we have 3 chars, okay? So A, B as integers, Z as a double, and we have 3 separate chars, char 1, char 1, char 1, and char 2. So now we got 36.78B34. So Z is a double. So in this case, 36.78 will go to Z perfectly fine. Then we have CH. CH is a char, so we got 36.78 as Z, B as CH, and 34 is an integer. So that's perfectly good too. So perfectly good, all right? Works out well. Put a big check mark. The next one, C input Z, and then CH, and then A. So this one, same as the other one, Z or Z, CH, and A. 36.78, that's the double. New line, B works for the char, that's perfectly good. And A works as an integer, so 34 works as well. Yeah, so 36.78 goes to Z. The char is B, so it's got single quotes around it. And 34 is the int. Perfect. Put a check mark there. Next one, A, B, and Z. So int, and double. So here we have 78.49. All right. So wait, no, sorry, 1134, right? Yeah, this way. So A, B, and Z, 2 integers, and then a double. So we have one integer, 11, because it's consecutively typed, so that does count as 1. So 11 goes to A. White space means it's going now to the next variable, which is B, and B is an integer, so the next 2 characters are good. 34 is B after A was 11. And then there's nothing else, so nothing can be assigned to Z, okay? Next one, A and Z, 78.49. So in this case, 78 is an integer, so that's perfectly good. There's no space, but the period or the decimal sign means, oh, it's a decimal, so yes, because the decimal doesn't have to start with a number. It'll be assigned as 0.49, but it's still a decimal. So 78.49 for A and Z works perfectly good. 78 is the integer, and 0.49 is a decimal. Check mark. All right. CIN, CH, and A. So CH is a char, A is an integer. So here, CH and A. So 256. Well, 256 is going to go based on this. 2 is a char. It's a character because 2 does not. 2 represents not the number 2, but the single quote. 2 single quote, which again means it's a way different than the number 2, but it is a character because remember a character is one space, it's one character, but that character can be a number, it can be a letter, it can be a space bar, it can be a semicolon, any other character counts. So yes, the character, sorry, in this case is the 2, and that means, sorry, in this case, number 5 is the 2, and that means the 56 is assigned to the integer, okay? The next one, though, is different because now we have the A, it's the same number, 256, but we have A and then CH. Well, A is an integer. 256 is a whole integer. There's no spaces. So it doesn't just take the 2. It doesn't take the 25. It takes all 256. Okay? Because it's not a char. It's an integer. Integer is a whole number. 256 is a whole number. So therefore, okay, so I'm off by line all the time. Sorry. So again, line 6 here. So 256 goes to A, and then there's nothing for the CH. So we're waiting, assuming anything else comes. Otherwise, it sits there. And then the last one, I guess, CH1 and CH2. So A is CH1, then a space. White space is ignored, but it goes to the next variable because of the white space. CH2 is another char. So again, B, it works perfectly. So CH1 is single quote, capital A, single quote. CH2 is a single quote, capital B, single quote. All right, we're not getting real far, but hopefully that's helping you. All right, so now, using a predefined function in a program. So when activated, it accomplishes a task. Obviously, a function is a subprogram. It's a set of instructions. We talked about that when we were talking about chapter 1. Okay, so main executes when a program is run. Okay, other functions execute only when they're called. We're going to be calling these functions many, many times, starting in a couple chapters now. Okay, but we're getting closer to using these things. Header file may contain several functions. So we've talked about our header files, right? Our pound include that we're adding for this one is string, and pound include IO manip. They both will have less than. So pound include space less than string greater than, pound include space less than IO manip, IO manip greater than, and then that would be the same. Okay, so but they work with functions. Right? So the IO stream, remember, we can do our coot, we can do our endl, we can do our cin with them. So they have predefined functions. With IO, actually show fill is also one. With pound include IO manip, fixed is an example of a function. Set precision with an open and close, because there's an argument required for set precision. So they're examples of the functions there, predefined functions. Okay. All right, so now to use POW. This is just another one. This is to use a POW, which means the power. It's like when you want to do 2 squared or 2 to the cubed or 2 to the 4th power, these kinds of things. You have to have another preprocessor directive. This one is called CMath. So pound include space less than CMath greater than. All right, so 2 numeric parameters. So we have POW, which again stands for the power function, and then x comma y. They're 2 required arguments, but if you look after the equal, it ends up being x to the y. Okay, so then in the little thing under it, in POW 2 comma 3, the parameters are 2 and 3. What it means is it's 2 cubed, so the 3 would be up top. Okay, and that means 2 times 2 times 2. So the answer of 2 cubed equals 8. Okay, so it's 2 times 2 is 4 times 2 is 8. If it was 2, 2, it would be 2 squared, 2 times 2. 2 cubed is 2 times 2 times 2 is 8. 2 to the 4th would be 2 times 2 times 2 times 2 is 16, etc. Okay, all right. Now, the sin and the get functions. So the get function, I mentioned the first slide when they had some of this stuff, inputs the next character, okay, includes white space. It stores in memory location indicated by its argument, meaning if the argument is for a char, it's a char. If it's an integer or if it's a double, it's an integer or a double. If it's a string, it's a string. So whatever it is that we're getting, all right? And what's the syntax? It's CIN.get, okay? This is called the dot notation, especially useful in Visual Studio, okay? The dot notation. So sin.get or cin.get var char, the var char is the argument, Okay, so it's getting the next char, and we're calling the var is just saying variable, and we're just pretending it's a char variable. So that could have just been easily cin.get open parenthesis num1, right? And if you wanted to preface it with a little data type int in little letters, and then big number meaning n capitalized, and then umber small, right? So it's that way. But anyway, so var char in this case is a char variable, and it's also the argument. Argument means it's between the open and the closing parenthesis. All right. So there's also an ignore function. I think I said this on the first slide too, but I don't remember now. So with an ignore function, what we're doing is there's two arguments in this case. All right. So the first argument in this example is an integer. Okay. And so we're calling it int and then expression. Okay. Whatever this int expression is, it's an integer number. So it might be the number 10 as an example. And then the comma, the ch expression might be looking for like an end line, right? Okay, so, or it might be a new line, but it's something that's a char. It could also be a capital letter A or a little a. It could be a space. It could be whatever it's looking for. But the point is, it'll ignore, once it sees this, how many spaces is this thing? So let's say it says 100, then it's saying, I ignore the next 100. Or whenever you find this, whatever this character, remember this one character from the typing, from the keyboard, all right? All right, so if int expression is a value m, the statement says to ignore the next m characters or all characters until the character is specified by chexp, meaning this character. Okay, so that's what we're doing. All right, so now consider this this declaration. So here we have an int a and we have an int b. So int a comma b means two integers. They're both, that's just our declaration of those two variables. And then we have some input, and we're saying here 25 space 67 space 89 space 43 space 72. And then for whatever reason, they're showing them on the next line, but that doesn't matter. So there's a 12 space 78 and space 34. So remember, we're looking for integers. So obviously all of these, so we have 1, 2, 3, 4, 5, 6, 7, 8 integers as the input. And now we're looking at some statements to help us figure out what they want us, what these statements will do as it relates to the ignore function. All right. So the first statement, CIN greater than A, what's it going to do? Well, here's the input, right? And it's going to ignore anything beyond the number. So the white space is ignored because it's only asking for one integer. So at this point, A would be the 25. So stores 25 because that's the first number. The second statement here says sin.ignore, or again, cin.ignore, and here's the two required arguments. The first argument is the number 100. So that says discard all of the remaining numbers in that first line. So all the remaining numbers, there's, you know, all these, there's not all really, it's only a total of 8 bits, but I mean, in terms of numbers, it's 4 numbers, and they're talking about characters. So characters really are including spaces too. So it's basically the first space, the 6, 7, the space, the 8, 9, the space 4, 3, the space 7, 2. So whatever that comes out to, 10 or 11 characters is what's ignored. But since they're going up to 100, obviously it for sure takes that line out of play. All right. But then it also has the \n, which means new line. And for sure, after the 72, they most likely did a new line to get these last 3 numbers down here. So I'm guessing that that would have been that. And either way, though, it's ignoring. It's not doing anything with them. That says to ignore these. Okay. So then on the C in B, B is also an integer, remember? So the A was the number 25. Then the second part, sin.ignore, means get rid of all this stuff that's beyond it, okay? And then the new line is where we're going to get the B, and that's number 12. Right? So the number 12 is going to be there. All right, put back and peek. So put back, again, places a previous character, extract it by the get function, from an input stream back to the stream. In other words, oh, shoot, that last character, I don't need. I want to put that back, all right? And the peek function returns the next character from the input stream, but only to let us, quote unquote, take a peek at it. It doesn't actually remove the character from the stream. Otherwise, everything does remove the character from the stream, okay? All right, so the put back and peek functions, slide 2 of 2. So in terms of the formatting or the way the code is, it's still using dot notation. So iStream var, meaning, again, iStream var is an iStream, which is the input stream, a variable. So whatever that variable is, we're wanting to do a put back one character. And it's always the most recent character. Okay, so that's automatic. So it's iStream var dot putback. Again, dot putback means you'll get, if you're in Visual Studio, you'd get IntelliSense for it. If you're doing this at REPL.IT or if you're doing this at MindTap, you may not get the IntelliSense, but code-wise, it's perfectly good code for the compilers at REPL.IT and at MindTap. Okay, and then again, the argument, anything after an open parenthesis and before a closing parenthesis, that's called an argument. And your semicolon obviously ends the code statement. So iStream var, the input stream, such as cin and ch is a char variable. Syntax for the peek, same thing, but now we're putting the ch because we're wanting to look at just one character. So ch equals iStream var, and again, dot for dot notation, dot peek is valid with the input stream. Okay, so in stream or iStream var means the input stream variable for that, and we want to just take a peek at it. Okay, in this case, the argument is an empty string because we only want to look at that one string, well, one character, and we're not retrieving it, we're not pulling it, we're just peeking at it. All right, so that's dot notation. So I just told you about that statement, cin.get, ch means it's getting the next char, and it's going to getting it from the user, meaning whoever's typing the information in on the keyboard. Could also, though, be getting it from a text file. So remember, text files are also input streams. So it's called the dot notation. The dot separates the input stream variable from the member or function name. The function name is this part, the get. The input variable is this part, the cin. Okay. All right. In C++, the dot is the member access operator. We just call it the .NET notation. Things can go wrong during execution. This is what I was talking about a little while ago when I mentioned the term, or when I talked about a character, and then I went back to go online to find out what a character 9 was, and I said that 0 is a 48. I think it was 48, so a 9 was about a 57. And the point of me doing that was just to let you know that a char 0, so a single quote 0 single quote, or a single quote 1 single quote, is not the number 0 or the number 1. It's a char. Okay, so just always remember that. So if you're putting ch, meaning chars, into integer or doubles, you're going to get an input failure. Can't work. All right. All right. So now, I don't know where we are, slide number, I guess 24 maybe. So, oh, you know what? I said I was going to be playing these from the F5. Sorry, because you guys probably can't see them as well. So let's see. I hope it stays on 24. Ah, darn it. Let me go down. Okay, yeah, this shows me the number in the bottom right. So 24. Okay, so 24, the clear function. So if you're in a fail state, meaning you had an error based on some problem where you were taking some char variables and trying to assign them to a double or to an integer variable, it won't work. The only way to get your code working again is to do iStream var dot clear. Dot, again, it's that dot notation. And dot clear is an empty argument. But empty argument means, again, you need the open and you need the close, but you just don't put anything in between them. Sorry, that was a drink of my powder protein thing that my wife buys me. All right, so that's that one. So C out when used with less than, well, you know that's just what's going out to the formatting output to the screen, right? So to the monitor. We've done this many times. Manipulator, but it's really IO manip, okay, is used to format the output. All right. And N-to-L is not talking about manipulator. It's just talking about an example in your COOT. Remember we said that C output allows you to have things like your N-to-L, or your iStream, sorry, allows you to have CIN, COUT, and also N-to-L, right? All right, now we have set precision. So here we're doing some manipulators though, and these are important to understand at least a little bit. So when you have a set precision, you want to store, or you want to allow your numbers to have X decimal places. The norm is to have set precision, and then this is a required argument because there's a variable, there's a variable in between with the value, or it's just a hard number in between. Normally it'd just be set precision, open parenthesis, 2, close parenthesis. And that will always output decimal numbers with up to whatever that number of decimal places are. And to use it, you have to have the pound include IO manip. You will definitely be doing this in your chapter 3 programming exercises on. And you don't use set precision by itself, by the way. So really, they should have started with fixed and show point because they're all next to each other. Okay, so, but set precision is the most important of them. So really, it would go COUT space less than, fixed, and then not a semicolon, but another less than, and then the show point and fixed don't have arguments, so they're just those words by themselves, and then another less than, and then the set precision with the required argument, the open close parenthesis, and the number 2 or 3 or 1 or whatever number you want in between. All right, so that's how that works. So show point forces output to show the decimal point and the trailing zeros, but show point is not technically part of IO manip. It's actually part of IO stream, but you can't use it by itself. All right. So again, you see how they're doing it? Even though they're putting, yeah, you can have a COOT show point, but what they're showing is C output less than fixed, then less than show point, and then really, if we go back those 2 slides to the first one that was set precision, that's after this one. So less than set precision. Okay, with an argument of 1 or 2 or 3, whatever number in between that you want to accommodate those many decimal places. All right, now reading and writing of long numbers can be error prone. So all this thing here, C++14, this is like a newer rendition of C++. Basically what it means is that this is a number. Like if you look at this number, you can't read what it is. This way you can say, oh, okay, so it's 87, but you still got to check over here. 87,523,872,918. So it's 87,523,872,918. But over here, you start here 3, so that's the hundreds, or the up to the hundreds. This next 3 is up to the thousands. The next 3 is up to the billions, and then the millions, and then the billions. So it's just very hard to see, right? This is the way with C++14 you can put single quotes to separate them. But I think you remember from either, well, you might remember, but in either chapter 1 or unit 1 or unit 2, I mentioned that you cannot put commas in big numbers in C++, because by having a comma, it assumes that's being a new number after the comma. Like and the variables, remember I said, let's say again with double test num 1, I can then say comma, test num 2, comma, test num 3, comma, test num 4, and then close. Meaning if I'm having open parentheses for all those numbers, or then I have my semicolon at the end. But point is, and actually, sorry, it's not an open and closed parentheses. It's just like, all right, double test 1, comma, test 2, comma, test 3, test 4, test 5, and then your semicolon. But the commas are not meaning it's one number, one huge number. Each of them is separated, right? So we can't use commas in numbers in C++. So with C++14, they just said, all right, so now with big, huge numbers, you can put, and technically it can be anything that has 1,000 or higher, you can put the single quote mark if it's C++14, but that's not a big deal in this class. We won't be doing stuff with those kind of numbers. All right, and then there's a set width, which is called set W. This is also part of IO manip. So to use set W, you also need pound include space less than IO manip greater than. All right, so what set W is basically setting the width of how many columns you want to accommodate. So if you got like some big double numbers where let's say 123.456789, whatever that is anyway, that's already at least 6 decimal places. So you can have a set W, and again, a required argument in between. In this case, that means you would have 5 columns. So 5 columns obviously means you could have at most 5 characters in the column for that number. So you can change these depending on what you're trying to do. All right. Now, there is a little bit of irony, though. If the number of columns exceeds the number of columns required by the expression, it'll still override this. But technically, that's not normally true, because you don't just have set W here. Normally, you have this after you've already got a fixed less than, show point less than, set precision. And normally, set precision is done with 2. But if you don't change set precision, then this width here is not going to allow it to override. So that statement here is not quite right. Anyway, and then there's also a right justification, which we use the term right for. It's a keyword right and a keyword left if you want to fill it up on the left side as opposed to the right side for output. Okay. Additional set fill. So set fill is like if you have some empty spaces and you want to have maybe a pound sign before those, then you could use the set fill with a pound sign. Okay. You can also use the left and right manipulators if you want to set it up that way. Unset F is something you don't normally use. It just basically means, well, even though I've got the set fill on, now I don't want to use it. So it's better to just take it off. But set fill is kind of cool, and it's easy to use because you get to do things with numbers. Here's an example, actually. So here, output stream variables can use set fill to fill unused columns with a character. So OStream file, remember this means outstream file. So the outstream is less than, because it's like the C output, okay? It's iStream bar would be greater than, because that would be input from the user. In other words, CN. So anyway, set fill and then the char. Char is just whatever that variable is. That doesn't do anything. But an example, if you want to put something in for the char, because char is 1 character, so you'd put a single quote, and a pound sign in between. Some people use asterisks. So single quote, asterisk, single quote would fill it with asterisks. Some people do it with question marks. Single quote, question mark, single quote. But in any event, that just, with set fill, it means any extra spaces. Like if on your set W, you're using a width of, let's say, 10, if you only use 6 of them, then you would have 4 pound signs on the left side of it here, okay, if you wanted to do that. Left manipulator, same, it's just doing this. Left justifies the output. Again, I'm not going to talk about disable. You don't need to disable. Right manipulator, if you want to right justify your output, is just, again, taking your your stream. In this case, it's the output stream, meaning it's the file you're creating, the text file you would be creating. That's the one where you're doing the less than, the input file that you're getting from, in this case, like in, I think I said programming exercise 3-5, I believe is the one, but they're giving you a text file. Okay, so that will be, you'll code it with the greater than, because that's like the C input, but in this case, a text file. When you're wanting to do something to the file you create from the input file, then you do it with less than, right? All right, 2 types of manipulators, those with parameters and those without parameters. So set precision, remember, so you need the pound include space less than IO manip greater than preprocessor directive for set precision, set W, and set fill, okay? So you need it for those. Manipulators without parameters require the IO stream. So the fixed and the show point, okay, fixed and show point, you end up using with IO stream if you're going to use them, meaning the pound include space less than IO stream greater than, all right? But the most important one in this chapter is set precision, and it will have an argument, so it'll be a less than, a number, and then a closing parenthesis. I said less than. Set precision, open parenthesis, a number, then close parenthesis is what I mean with set precision. Okay, and I'm going to again do one of these for you guys as a coding example, so don't worry too much about it. All right. So input, output, and the string type. So now we're again talking about the string type. I mentioned at the very, very beginning of my video. So in the first few minutes of today's video, I talked about a get line. I said get line is important and you have to use it. You may have to use it on the exam. I don't know yet, but for sure you're going to have to use it in at least one of your programming exercises from chapter 3. Okay, but what it basically means in this particular case is we're saying get a whole line from my iStream variable. So this would be like, let's say, a text file. Okay, but it doesn't have to be a text file. It could be anything. But they're using str basically as a short name for string, and then calling it string variable, string bar. Okay, so in other words, this string bar can be a whole line long. It can be a lot more than a whole line long. It can be literally pages. But anyway, so get line, open parenthesis, 2 required arguments. What file in this case we're talking about, or it may just be what a text file. So anything that we're getting. And then the variable has to be after a comma, and that's what we're going to assign it. When we get it, that's where we're going to be looking at it if we're wanting to then review it or search for things. Remember, string manipulation is the whole reason to use pound include. So this is the same thing again. Pound include space less than string greater than. Okay, all right. Debugging, understanding logic errors. I think I talked about logic errors earlier. So syntax errors are reported by the compiler. Logic errors are typically not caught by the compiler. Spot and correct using COOT statements, meaning, again, test your code, right? If you're doing a formula, and even if you just think, I'm not sure if I'm doing something right or not, let's say you put in a couple numbers, like let's just say it's a simple thing for where a company has product prices, and maybe they don't have any product prices over, let's say, $100. Otherwise, they assume there's a big error. So you might want to do a C output statement on any program that's running where it's showing prices and verify. Literally stop. You might want to stop at each one. But realistically, what we would do in chapter 4, which would be when we're starting to use if statements, we would actually then say if, and that's just say product price greater or equal 100. Then stop the program, okay? Or put a message, hey, this is a problem. So it's logic errors. It's a matter of how we can pick up logic errors. They're not syntax errors, remember, so they're going to run. So we got to prevent them from causing problems. Once we take away any problems, and if this is coming from a database, think of product prices in a database. There could be thousands of them, right? So once you correct it, then you can remove that output statement from the program. All right. File is an area in secondary storage to hold information. I mentioned that we're doing some input file and output file work in this chapter, but only one that's required. Okay, so we have to make sure that we know what we're dealing with. But basically, it's a 5-step process. We have to use yet another header. This is called file stream. So F stream. So pound include space less than F stream greater than. This file stream header is what allows us to then use the input file stream and the output file stream variables so that we can pull information from a text file and then create another text file called an output file to save whatever we do with our C++ program with that input file. Okay, so we need the F stream header. We need to declare a file stream variable for the in file, what we normally call in file, and another one for what we call the out file, based on the fact that they're file streams. Okay, so we declare, we put a pound include statement, and then we have file stream variables. We have to name those variables and then put those variables to a text file in the case of this chapter. Then we associate the file stream variables with the input output sources, meaning the text files. And that's how we open the file. And then we use the file stream variables with greater than when it's on the input side, less than when it's on the output side, and then we close the files. Okay, quick review. So stream, an infinite sequence of characters from a source to a destination. The input stream is from a source to a computer. The output stream is from a computer to a destination. The source and the destination in this chapter's example will be a text file. The input stream will be a TXT file. The output stream will either be a DAT, which is a data file, but really it is a text file. So DAT or TXT, depending on what they tell us to make, but they're the same. Okay, just one ends in a .dat for data, one ends in a .txt for text. We know CIN is common input. We know COUT is common output. To use CIN and COUT, we know we have the IOStream header. We know get reads data character by character. It's one character at a time. We know the ignore function skips data in a line. We know the putback puts back the last character retrieved by the get back to the input stream. And we know the peek returns the next character, but it doesn't remove it. It's just letting us preview it. And then attempting to read invalid data into a variable. This is the primary cause of these is char values into input, into integer or double decimal types, double data types. Attempting to read invalid data into a variable causes the input stream to enter the fail state. The manipulators, set precision, fixed, show point, set W, set fill, left and right can be used for formatting the output. You must include the IO manip, that's that header again, preprocessor directive, so pound include space less than IO manip greater than for set precision, set W, and set fill. The header, again, meaning pound include, so pound include space less than F stream, where F stands for file, and then greater after the stream, contains the definitions of the input file stream, so that's going to be our in file stream, or variable, if you will, and the output file stream, okay? And that is that. All right, so guys, that is that one. Please read the chapter in the ebook from in your MindTap. So in MindTap, oops, I'll just say I'm still here. Go over to your blue book. That's your full book, remember. This is chapter 3. I may not still be here. Yeah, I am. So table of contents. Chapter 3 is input output. This one's only about 40 pages, but it's a lot of work for 40 pages, okay? I mean, a lot of important material. All righty? So have a great day.